Hello, ladies and gentlemen, Root Beer here, and I hope you're ready to try question number 23 on the 2009 Fermat. If you're not, feel free to pause the video and try the question out for yourself. If you want to, download a copy of the contest, or here, I've switched, and if you can make it out on your resolution, here's question 23. Feel free to pause it and try it out for yourself. Good? Ready to go? Alright. So question 23 says, suppose that A, B, C, D are positive integers and they satisfy these equations here. AB plus CD is 38, AC plus BD is 34, AD plus BC is 43, and we just want to know what's the value of A plus B plus C plus D. Alright, what can we do here? Now, the equations are looking kind of nice. Not bad at all. You know, it's a pair and then the other two, and we multiply them together and add them up. So, is this every possible sort of pair? Make that 3 a bit more pronounced. The software I use likes to cut corners. It assumes I make mistakes, and let's be honest, I do make a lot of mistakes. What have we got? AD, BC. Oh yeah, it's just the other ones. And then it was 43 down here, and I think 34? Okay, so I've got the question fully copied. My instinct tells me add them all up, and I'm not sure this is going to go well. But AB plus AC plus AD plus CD plus BD plus BC is, oh gosh, what is that? 38 plus 34 plus 43. So that's 115. Alright, what has that done for us at all, if anything? Not entirely sure. So this is all possible. If I've got if I've got 4 numbers, and I just want to choose 2 of them and multiply, there's only 6 ways to do this. And so we do have all 6 ways, but what does this tell us about A plus B plus C plus D? Because that's what we want. I don't think we can actually get A on its own, B on its own, C on its own, and D on its own. Well, maybe we could. Maybe we could. I'm starting to think that maybe there isn't some sort of clever way to add this up, and instead we're just sort of, I don't know, I guess gonna have to reason away. I mean, the fact that they said positive integers makes me suspicious. Makes me think there isn't some nice slick way to do this question. Of course there might be, and I'm just missing it. Well, if adding them up isn't going to help, would subtracting help? Because these equations are nice, it'd be a shame to waste them the way they are. So maybe AC minus B, or plus BD, and that's 34, and if I subtract, I'll get A times B minus C plus C minus B times D is equal to 4. And that's A minus D times B minus C. That's equal to 4. Okay, well, if they're integers, that sort of narrows things down a little bit, because there's only so many possibilities I can have for A and D and B, C. And I suspect if I combine the other equations, I'm going to get similar expressions. But is there one that's particularly helpful? Oh, 43 and 38, that would be a difference of 5, and that's prime. So I suppose I could try that. So that's, yeah, because that one's 9, that's not going to help. AB plus CD is 38. And when I take the difference there, I'll get A minus C times D plus C minus A times B is equal to 5. So A minus C times, I think we specifically want D minus B. is equal to 5. All right. So the only way that this is going to work out is if we're looking at 5 times 1 or negative 5 times negative 1. Not necessarily in that order, but that does tell me one of these numbers is 1 more than another. You know, for example, we might have C is A plus 1. Or we might have A is C plus 1. So is that the right approach? I suspect it might be. It might be. It's kind of hard to tell what's going on here. I suppose we could get the next equation up. Here we're going to have a difference of 9 when we subtract. AC plus BD. And now I'll get A minus B, D minus C has got to be 9. So now we're looking at 9 and 1, 3 and 3, negative 3 and negative 3, or negative 1, negative 9. And over here we had 4 and 1, 2 and 2, negative 2, negative 2, or negative 1, negative 4. Alright, so I guess really the only thing to do is just sort of make an assumption. I think that's what I'm going to do. I'm going to focus on that prime thing. I'm going to say, all right, A minus C is 5. Maybe this is true, maybe this isn't. B minus D is going to be 1. So what does that tell me? A is C plus 5, and B is D plus 1. Okay. And then, well, let's focus on this A minus B and D minus C equation. So we also know 9 is A minus B and D minus C. But I just said that A can be done in terms of C, and B can be done in terms of D. And so what do we have? We'll get C minus D plus 4. And this guy here is negative C minus D. So, okay, negative 9 is C minus D plus 4 times C minus D. So we still have to have this nice factor. And so I'll either have negative 1 and 9, or I'll have negative 3 and 3, or I'll have negative 9 and 1, or no, that's kind of it. And none of these factors are 4 more than another. So I guess this can't be true. Have I made an error somewhere? And I don't think so. So, yeah, what can we do now? I guess so. Our assumption that A minus C is 5 and B minus D is 1 is wrong. Could I have A minus C is 1 and B minus D is 5? Because if not, that narrows it quite specifically down to the minus 1 minus 5 case. And so then A would be 1 plus C, B would be 5 plus D, and then we'd still have 9 is 1 plus C minus D plus 5, D minus C, and so we'd still get negative 9 is C minus D minus 4, C minus D. And again, we run into the same problem. We don't have a pair of factors that differ by 4. So I think this is just impossible here. Okay, so, and I guess A minus C could be negative 1 and B minus D could be -5. And then in that case, A is C minus 1, B is D minus 5. I don't see this going any better, though. Unless I've got my equations wrong. I don't think I do. So A minus B, D minus C, and that's going to be C minus 1 minus D minus 5, D minus C, and that's going to be C minus D, and -1 plus 5 is a plus 4 again. This just isn't working, so what am I doing wrong? So I subtracted that, fine, that is 9. That's fine. AD minus AC is A times D minus C. BC minus BD is B times C minus D, but flip it around, it's -B times D minus C. So we're fine. So what's going wrong? I haven't copied a pair of numbers wrong. And they're positive integers that satisfy this. And 43 minus 38 is 5. There's my problem. It's A minus C, and then it's D minus B. Right? That's really the only problem there. A minus C, D minus B. I had that order wrong. Does that really fix things up enough? So we'll try this out. So A is 5 plus C, and D is 1 plus B. Now, instead of that 9, let's get the one that had A and D together. So A minus D times B minus C. A minus D times B minus C. A minus D times B minus C. Okay, so that's going to be 5 plus C minus 1 plus B times B minus C. We'll get 4 plus C minus B. And I'll switch this around to a C minus B at the cost of a minus sign. So we'll put the minus sign out here instead. So we'll get -4 is 4 plus C minus B times C minus B. And what are the possible factors we could have here? We could have -4 and 1. We could have -2 and 2. That's the one we're going to need. And we're going to have, or we could have -1 and 4. So we're going to have that middle one. And it's going to quite specifically be 2 here and -2 here, because I have to add 4 to one factor to get the other. So C minus B is -2. And that tells me C is B minus 2. And that tells me A is 5 plus B minus 2. And that's going to be B plus 3. So now I have everything in terms of B. Okay. What can we do now? Oh, I already have this written out. Didn't realize I used 2 other pages, or 1 other page. We also have this third expression involving 9. 9 is, and now everything is in terms of B. So what can we do here? Everything's A minus B, C minus, or D minus C. A minus B, D minus C. Alright, but A is B plus 3. D is B plus 1, and C is B minus 2. And we're going to have 3 times 3. Well, that's annoying. Okay, don't need that. That just sort of confirms what we already knew. So, how can I figure out A plus B plus C plus D? It's going to be B plus 3 plus B plus B minus 2 plus B plus 1. And that's going to be 4B plus 2, but that doesn't... Oh, maybe that's enough, because we know they're integers, so this has a remainder when we divide by 4. Remainder of 2 when you divide by 4. 15 doesn't have that, 16 doesn't have that, 17, 19, only D, 18, has a remainder of 2 when we divide by 2. Is it possible there's multiple ways to... multiple answers, but there's only so many that are integer answers? And, yeah, so I'm going to leave 23 there. I'd be curious if anyone out there actually has been able to work out the A, B, C, and D, and if that's the way you did it, or is that something you did for fun after the fact. So I know they have to add up to 18. Oh! Okay. Because I know the answer is 18, but only by process of elimination, I can figure out, okay, D is 4, that means A is 7, or sorry, B is 4, A is 7, C is 2, and D is 5. But I don't think I could have deduced that if I didn't have those 5 possible answers. So what I'm really asking, and leave a comment if you managed to do this, did you work out A, B, C, and D separately, using the integer knowledge, but not using the 5 given answers to narrow things down like I just did? Okay? I mean, what I did was perfectly fine, because sometimes that's the strategy on a multiple choice contest, but it's a weird question. A good question. I like weird. I like things that challenge me. I thought this was going to be the casual, add them all up and then neatly factor things. But I gotta expect better, I guess, from the Fermat. It's the grade 11 contest. But leave a comment if you'd like to, if you did manage to get A, B, C, and D without having to look at the presented answers. And either way, up next will be question number 24. I'll see you for that in the next video.